Cast is now starting. All attendees are in listen-only mode.
Just wanted to welcome everyone who's here so far. Thanks for getting here a couple minutes early. We're going to get started here in about 3 minutes. So yeah, we'll hop back on here and get rolling. In the meantime, we've got some handouts that are under the handout section of your webinar tab. So feel free to take a look at those, and we'll get started here very shortly. Thank you. All right, we'll wait another 30 seconds or so here for a few more people to trickle in, and then we'll get started. All right. Thank you today for everyone who is joining us here for our presentation. Today's presentation, as part of our CivicSolar webinar series, is called Solar Standards. What is the SunSpec Alliance? So before we start, just a couple housekeeping items here. Wanted to let everyone know that the slides should be under the handout section. I actually did have somebody mention in a question before the presentation began, they were not seeing the handout section, so we will be sending out some of these after the presentation. But wanted to let everyone know primarily that during this presentation, you can ask questions for both the panelists as we move along here. So feel free to type your question into the box throughout the presentation, and we're going to devote a solid 15 minutes or so at the end to go through all those questions. A reminder that we'll also send out a recorded webinar to all of the registrants. And lastly, if you're here looking for a NABCEP credit, we'll be providing those instructions at the very end so you can get that continuing education credit. Great. So it's my pleasure to introduce today's speakers. We have both Tom Tansey, Chairman of SunSpec Alliance, and Chris Connell, the National Tech Advisor from Fronius. Tom is a chairman of the SunSpec Alliance, where he leads the distributed energy industry's efforts to establish data and communication standards that really enable seamless integration of solar PV and storage onto the smart grid. Tom has served as a board member of the Solar Energy Finance Association and also as a general manager and vice president of business development for Power One, which is now a part of ABB. And Tom really got his start as well in the solar industry, working as the VP of business development for a company called Fat Spaniel, which pioneered solar as a software service and dealt with monitoring. And for Chris, he's held multiple positions within Fronius over the past 7 years. He's currently the National Technical Sales Advisor, where he focuses primarily on the East Coast. And as a former aviation technician in the U.S. Navy, he brings a wealth of technical information with his background and is able to bring extensive knowledge to the entire Fronius sales team. So just wanted to provide an outline for today's presentation. So here are the main topics we'll be diving into today. First and foremost, why is NEC 2017 a significant electrical code update for the solar industry? I'm sure you've heard about it recently. We'll dive into more of the specifics there. Next, we'll talk about how the Fronius Symo advanced inverter complies with rapid shutdown requirements. And we'll also dive into why our industry should care about the SunSpec Alliance's mission to create de facto standards for our industry. So we'll dive into, as the title of the presentation suggests, what exactly is the SunSpec Alliance and why is it important for us? And lastly, we'll have our Q&A session. So just another reminder, keep submitting those questions as we move along. So now, we're very briefly just going to go over the background of each of the representatives here in today's presentation. First, as a CivicSolar representative, most of you are likely familiar with our service offering, but we are a solar equipment distributor, and we focus on design and engineering services in addition to procurement for our solar installers. We're all about reliability and responsiveness with our installers. And we pride ourselves on having an accessible website for our installers as well to learn more about technical material within the industry and also place their orders online. And with that, I'm very excited to hand the mic over to Chris, who's going to give us a little background on the Fronius company.
Thank you for having me here and hosting the webinar, Tom. Diving right into it, Fronius started out in the 1940s by a man named Gunther Fronius. His vision was taking car batteries, which were being thrown away, and finding a way to recharge them, thus creating the first business unit within the company called Perfect Charging. He realized that this technology that he created could be used for the welding technology, so he created the second business within Fronius called Perfect Welding. He had a goal in doing this to change the industry, and several years later he did. He created CMT welding, or cold metal transfer, which allows us to weld aluminum and steel together. His son, Klaus Fronius, took over the company and had another vision. He had a dream of offsetting all the energy needed for the battery charging and welding with clean energy, thus creating the solar energy business unit. Over 8 gigawatts and 1 million inverters sold. This vision was greatly surpassed. So what ties all three of these business units together? And that's, as shown, energy conversion, going from DC to AC and AC to DC. Our company doesn't have short-term goals. Our vision is long-term, and SunSpec is a part of that vision. Our long-term vision is 24 hours of sun. Visit 24hoursofsun.com to learn more. At this time, I want to pass it over to Tom from SunSpec.
Great. Yeah, thank you for that introduction, Chris. And good morning or good afternoon, everyone, depending upon where you are in the country. My name is Tom Tansey. I'm the chairman of the SunSpec Alliance, and I'm really pleased to be able to present to you all. SunSpec is in the business of developing and defining de facto standards. These are standards that can be put into place immediately and fill important gaps. Our company is now in its 10th year. We're a global alliance of solar and storage companies. We have over 100 member companies now, and overall, we probably work with around about 1,000 constituents through various activities that we have in standards making and various research projects that we do with the Department of Energy and the various states around the country. As was mentioned, our mission here is to define these standards for solar so that distributed energy can be put online in high volumes. And in order to do so, we really focus in on usability, so plug and play interoperability is the goal. The idea is that you want to connect A to B without having to think too much about it and just know that your system is going to work. That's increasingly important these days as both the rapid shutdown standards of coming into play, where we're having solar modules talking to inverters over the DC power line, and also in utility interconnection, where distributed energy systems now will be required to be directly tied back to the utility, specifically in the state of California now, but we can expect this to propagate across the rest of the country and to a certain extent in the state of Hawaii as well. So there's communication standards there that you'll need to be cognizant of, and we'll cover those at another webinar, I'm sure. The overall idea, though, is with SunSpec operating as a nonprofit trade alliance is to drive down cost and drive up innovation. We could see that IT was going to come into the mix here at some time and be really a key enabler of efficiency, which then allows us to keep the solar and storage and this distributed energy industry growing. So grow the size of the pie for everyone to create more business for all through these interoperable, interchangeable standards. You can also think of SunSpec as setting a benchmark for quality and performance. We're going to talk about our certification program later on today, but this is not a safety certification per se. You get that from the various IEEE standards and UL standards and so forth. But what we're concerned with is communication interoperability. And so there, again, the mark of excellence there is how easy is it to use and how reliable is it. So that's what you can think of when you see the SunSpec mark. So that's a quick overview of what we are. We'll get into a little bit more as time goes on. So at this point, I'll turn it back over to my colleague to handle the next part of the webinar.
Thank you, Tom.
Back to you, Chris.
So taking a look at NEC 2017, what states have already adopted this? The major states that have adopted this is Minnesota, Texas, Colorado, and Massachusetts. Much of the Northeast has already adopted this, as well as the central states. This equates to about half of the states in the U.S. are on NEC 2017. By the time 2020 comes around, expect nearly the entire country to be on NEC 2017. California, Florida, they've already locked into January 2020 for NEC 2017 adoption. So what is rapid shutdown? What are the major changes? If you can go on to the next slide for me, Tom. So the major changes apply to 690.12 in the section of rapid shutdown of PV systems on buildings. So there's a couple different terms in here, and it can get a little hairy if you're not familiar. You have array boundary, outside the array boundary, and inside the array boundary. With the major change being inside the array boundary. So the array boundary is defined in NEC 2017 as 1 foot around the array. And NEC 2014, it was 10 feet. Outside the array boundary, controlled conductors need to be at 30 volts within 10 seconds. So you can see here that those lines are not colored in because they are 80 volts or less. Then you have inside the array boundary, which the controlled conductors need to be at 80 volts within 30 seconds. And that was, again, the major change going from NEC 2014 to 2017, which requires module level rapid shutdown. Now this diagram is actually for 690.56 for buildings with more than one rapid shutdown type. You actually have to label this if you are adding to a system with rapid shutdown already with rapid shutdown already on the building. So at this time, let's pass it back over to Tom from SunSpec.
Great, thank you, Chris. Appreciate that. All right, so how does SunSpec come into the picture here? The National Electrical Code gets established in the 2013-2014 timeframe is when the actual revision was done, and the requirement for module level rapid shutdown comes into play. Then in September of 2015, a group of about 30 companies that are members of the SunSpec Alliance met with us at Solar Power International and basically said that we need to have a solution, a signaling solution to support this rapid shutdown signaling so that we know when the system is actually on or off. So we need to have a mechanism for turning the system off and de-energizing the panels. And we also need to know, again, if it is on once we restore the service back to the system. So that's where the project got kicked off in 2015. Then over the next couple of years, we met frequently, every week or every 2 weeks, and developed many different drafts of the standard. And then August of 2017, we published a specification, free and open, royalty free, so it can be implemented by anybody, that carries a signal across the DC power lines from the PV modules to the inverter to let the inverter know that everything's okay, that the system, the panels are in good health, and the system is good to operate. The device, of course, at the inverter has the ability, when you hit the activation switches, to de-energize that array, and the signaling system would carry all that information back and forth. So that happened in August of 2017, and then stepping forward to today, you're going to hear about the accomplishments we've made in adoption, but we've also opened up a certification program to mark these products that comply with SunSpec Rapid Shutdown, so that from a buyer's perspective and a seller's perspective, you'll know what products work with what, which modules, which inverters, and so forth. And this is an interchangeable standard supported by multiple module manufacturers and multiple inverter manufacturers, and it works the same way across the whole works. And the certification program is there to test and verify and prove that that's the case. So if we can go to the next slide. We'll talk about how the SunSpec Rapid Shutdown signaling system works. And it's pretty straightforward. As I mentioned, the signal is carried over the DC power line. Our objective in terms of defining a standard is to make it basically disappear. We're trying to do our level best to eliminate steps required to integrate these types of technologies. So in fact, there's a receiver device in each of the modules in the junction box of the modules, and then there's a transmitter device either in or near the solar inverter that carries the signal back and forth across the power line. But it's very straightforward because it's buried into the core technology. It's low cost. That means that you don't spend much time on site doing installation or special commissioning for this technology. And it has another benefit in terms of establishing system health every morning. So when the sun comes up, the modules come on, the beacon lights up and says, you know, I'm okay, I'm carrying the current voltage. And so that's an added benefit that comes along with this rapid shutdown safety solution. And so with that, let's move on to the next slide, please. And I'll just give you a little bit more of a background here of how this technology came together. As I mentioned, 30 companies met at SPI. We published 33 drafts of the spec over the next 2 years. So as I said, a very intense effort. Fronius was the very first to announce a compliant device, and basically 1 month after we approved the spec. So thank you to the Fronius company for being an early supporter, because it really helped to drive adoption. By January 2018, Tigo announced their product, and they had at that point tested with 23 additional companies, 14 PV module companies and 9 inverter companies to prove that the SunSpec signaling system worked. Texas Instruments then announced a chip in August of 2018 to further reduce costs and get directly embedded into the PV module. And in September 2018, once again back at SPI, 3 years later, we had a great coming out party for the SunSpec rapid shutdown ecosystem, and where we had, I believe, about 40 different manufacturers that had at that point announced that they were supporting this technology. And today, I think that the number is going up from there. So the growth has been fantastic. It means that there's a complete ecosystem. Last but not least, I want to sort of recount why this is important in the first place. This is about firefighter safety, and this is about consumer safety and installer safety. And so with this type of technology coming into play, it's just really another great tool in the toolkit of making solar the first and the best source of electricity. Okay, so with that, I'll turn it back over to Chris.
Thank you, Tom. As you saw on our previous slide, in 2017, we announced the first inverter capable of power line communication. The Symo Advance, built in with power line communication, is the way of the future. This is going to do multiple different things for installers. It's going to save on installation time. There's no needed component down at the inverter. So this is 100% built in. Let's go on to the next slide if you can for me, Tom. So our product comes standard with an integrated DC disconnect as well as the power line communication device, and it's going to lead to a very quick and easy installation. Our 208 models are ideal for ag and office buildings. Utilizing these inverters, you don't have to add a costly transformer, which usually comes with a 1 or 2 year warranty. So the entire PV system would be hindered by a 1 or 2 year warranty by changing to a 480 step-up transformer. And you can avoid this hassle completely. The Symo Advanced lineup is 100% field serviceable, making all the circuit boards inside of the inverter exchangeable. At Fronius, we believe in reducing truck rolls for exchanges, so with the product being field serviceable, you only need to make one. Let's move on to the next slide. At Fronius, we're committed to supporting customers by providing compliant solutions. Therefore, in the first step for module level shutdown compliance, Fronius offers solutions based on today's technology. Currently, what we have compatible is the Tigo TS4F to help fulfill with module level shutdown with our inverters, to support our installers with solutions for requirements in any state. This is the option that's currently available on the market today, and we believe that other companies will provide products to meet rapid shutdown compatibility with string inverters. When this happens, it will provide installers the ability to pick multiple different products to meet rapid shutdown. Fronius firmly believes in an open standard such as SunSpec, allowing multiple different manufacturers to work together, making up a PV system. At this time, let's pass it back over to Tom.
Great, thanks, Chris. Okay, well, so why should you work with the SunSpec Alliance? And I think my colleague here, Chris, at Fronius can attest to this. Industry growth is dependent upon industry standards at this stage. Globally, the distributed energy or the solar piece of that business is probably $250 billion in total, but it's gotten that way. It's grown very large in very large chunks, 10-20% per year growth, depending upon what part of the world you're in. It's not the conditions here in the U.S. now, but you get my point. Still, industry growth is quite high. In order to scale up, all industries follow a typical pattern of standardization, whether it's Wi-Fi, HDMI. We can have some other examples as well. Standards enable innovation. So with a standard, we can have a signaling system that goes over the DC power line that lets 50 different companies all plug and play. Now, the signaling system that we put together, it really is, its application in this case is to support the rapid shutdown system, but that same signaling system can be applied to other problems as well. So the next type of solution that we want to put into place that uses the PLC will be that much less expensive to innovate. Standards also enable simplicity, and that's what SunSpec represents, is standardization and simplicity, because if it's not easy to use, then there's a good chance it won't be used. So that's really the name of the game in the technology world, is can you make the technology disappear and simply add to the value and the experience of doing what you like to do, which in many cases is build PV systems. The bottom line is it's about first responder safety with a rapid shutdown system. And we really think that this is a key step in the development of our industry, where information technology capabilities are just going to become pervasive throughout PV and storage systems from here on out. And so we encourage you to work with us. Come to sunspec.org. For installers, EPCs, and so forth, we have a variety of different services that may be of use. Certainly, we have a strong educational curriculum on this technology, both rapid shutdown and on the interconnection standards like IEEE 2030.5. We do lots of work in O&M cost modeling. So if you want to benchmark your costs against your competitors and your partners across the country, you can do that. That's a project that we did with National Renewable Energy Labs, and we have a web application for that purpose. And so these are the types of things that you can gain by working with the Alliance. There'll be more in the future. We've spent 10 years developing standards. Now we're in the business of deploying them, and that means working with the channel. And so we really relish the opportunity to do so. So let's go to the next slide, please. Yeah, so the rapid shutdown ecosystem, we talked about this earlier. It's, certainly in terms of folks that have declared that they're in it and have shipping products, it's probably going on 50 companies at this point. So there's quite a number of different inverter companies, lots of different module companies are following suit, and I think you're going to see many more announcements in the coming days. What does this mean for you? It means that you don't need to change your supply chain habits much. You can still pick and choose amongst your favorite suppliers, but deliver on a critical feature, which is firefighter safety, which you need to do one way or another. With the SunSpec Rapid Shutdown, again, it's just built into the way a system's built. There are proprietary solutions. Many of them involve hooking up different types of networks, wireless networks and the like, and those are going to be more expensive, more trouble prone. And so we think that we have really come up with something here that really is quite special. The reason why it's special is that it has been driven by the industry. SunSpec has been relatively unsuccessful when it's proposed a new idea to industry, and it's been highly successful when we simply listen to the market tell us what to do. And so that's how we operate with, and we enjoy doing it because we enjoy making lots of solar energy to do our part to help this planet move over to a completely renewable platform. Okay, with that, I'll turn it back over.
Excellent. Thank you, Tom. So in summary here, to recap what we went over, looking at Fronius, they stand for innovation, quality, and service. And so, after installing over 1 million PV inverters worldwide, Fronius has built that reputation. And by partnering with SunSpec as one of the first inverter manufacturers, they continue to push the envelope when it comes to looking ahead in the industry and thinking about best practices from inverter manufacturers. In addition, the SunSpec Alliance aims to accelerate the growth of the solar industry by standardizing data operations across various product lines. So as we've seen, the Alliance works with hundreds of industry manufacturers, and this is all in an effort to create system efficiencies, which really helps streamline solar operations moving forward and improves the ability to have plug-and-play interoperability within the industry. Additionally, Chris talked about the Fronius Symo Advanced, which complies with NEC 2017 module level rapid shutdown by incorporating the SunSpec authorized protocol with the Tigo TS4 F add-ons to modules. In addition, we touched on this briefly, but ultimately the future of rapid shutdown bodes well for string inverters. As we look ahead, and we can get Tom and Chris's take on this as well, but as we look ahead in the industry, and as these discussions have begun with module manufacturers, it's more and more likely that the integration for rapid shutdown at the module level will be incorporated on module assembly lines to begin with, and that will continue to drive the cost of solar installations downwards. And lastly, as we saw on the last slide, the SunSpec rapid shutdown ecosystem has really bloomed in just a short period of time. Tom talked about how it's really only been 2.5 years since this was brought up at SPI. And so the ecosystem will continue to grow, and these conversations between inverter manufacturers and module manufacturers will continue to be supported by the SunSpec Alliance moving forward. So with that, I want to say thank you for your attention, and I'd like to open the floor here. We have plenty of time for questions. We already have a lot flowing in here, which is great. So to start it off here, this is a question for you, Tom. With respect to smart inverter rebates, is SunSpec involved in developing standards for verifiable reactive power? And this is in reference to three-phase inverters in terms of providing that reactive power capabilities to the grid. Is that something that SunSpec's involved in?
Absolutely. In several different ways. It says our business is standards. And so one of the standards that everybody will that interacts with on a daily basis is IEEE 1547. And that standard has just been revised. The 2018 version, as it was published last year in 2018, the test procedure is in the process of being published. That is the specification that governs solar and storage, anything that's on the customer side of the meter across the country. And for the first time, that standard requires standard communication interface. And you have three choices that you can choose for your standard: SunSpec Modbus, IEEE 2030.5, also known as SEP2, and the last one is IEEE 1815, also known as DNP3. The Modbus interface is present in 80% plus of power conversion devices, and so you can expect a lot of SunSpec Modbus out there. And in 2030.5, of course, is the default standard in California, so you can expect that as well. And that is actually a cousin of SunSpec Modbus. We contributed the DER models. But to your question, reactive power and rebates and so forth, it's defined in that context in those models, SunSpec Modbus 2030.5, 1815. And by all means, there is a mechanism for reporting that. We're also involved in a standard called Orange Button. This was funded by the Department of Energy, and this is for standardizing data interchange for solar finance and operations. The Orange Button standards, which has a series of terms that are harmonized to these interconnection standards, for things like reactive power. So you can get information off your monitoring systems, have it translated faithfully into your O&M systems or asset management systems, and then for reporting. So I know I was involved in rebate reporting and know that this can be a big hassle. It was a big hassle, certainly for us back in the Fat Spaniel days. And so that's the motivation for doing all this type of work. So sorry for the long answer, but there you go.
Great, thanks, Tom. And just a couple questions rolling in about the NABCEP certification. Wanted to let everyone know that if you email me with NABCEP in the subject line, I will send you back a certification for the 1 hour. So please do so by the end of the webinar, and I'll be sure to get that in your hands. Great, we have some more questions coming in here. Chris, this one's for you. Does Fronius require a TIGO module level device today?
So for installations on rooftop buildings in NEC 2017 states, that would be the third-party device to use, yes.
Great. All right, we have another one coming in here. Let's say a solar panel manufacturer says their panels are equipped with SunSpec, and we are also using the Fronius Symo Advanced. Do we still need to install TIGO optimizers for proper system communication?
Well, this is a plug-and-play standard. So, so from that standpoint, if you have a module manufacturer that supports the receiver for the rapid shutdown, then no, TS4 would not be required in that case, right? This is the whole point. But in this case, but this is but in terms of a third-party device for retrofitting, or some of the manufacturers have abstract OEM deals with TIGO, as you saw on the ecosystem slides, and so that may be, in fact, the way in which they've achieved SunSpec rapid shutdown compliance is by integrating TIGO.
Perfect. And Tom, without I'm sure there's information module manufacturers aren't willing to release at this point, maybe specifics, but could you just give the audience a general sense of how those conversations have gone with module manufacturers thus far, and their
Sure.
level of receptiveness in kind of taking this on?
Sure, absolutely. We've been in dialogue with them for probably 18 months, really. That's when the conversation started with the module manufacturers. The big concern is adding cost. They don't want to add cost. Second concern is adding complexity, because that's, those two things are result in having their products not ordered. And so those were really the big questions. And then the third question, I would say, was who else is getting in? So who's in the game? And so there we were able to say that quite a few of the big players and the core players in terms of electronics business, like TI, jumped in right away and built a chip for that purpose. And so that helped to assuage a lot of fears, and that's really what allowed all these different manufacturers to come on board so quickly. And I just see it accelerating at this point.
Great. I have another question here. This is it's regarding Midnight, actually, but it was talking about charge controllers and how they can potentially have issues with power line communications as they are noisier, quote unquote, than inverters.
Sure.
Is SunSpec looking into charge controllers as well? And how are you addressing that issue, if so, or is this primarily focused on the inverter communication?
Sure. I will note that the development of the specification and the technical content of the specification was developed primarily by the R&D companies, or R&D departments of the manufacturers themselves, and of which Midnight was one of them, a participant there. And with regard to noisy networks and so forth, probably the hardest part of achieving a standard in this space is dealing with EMI and FCC regulations. You don't want to inadvertently create large radio antenna out of a solar array. And so there's a lot of care that's taken to make that happen. But we sampled the different typical operating ranges and various types of noisy DC networks, and we picked, frequencies and so forth for our signaling system that look to be the most reliable most of the time, even in noisy conditions. So we think it's pretty robust in that regard.
Great. Is any SunSpec work applicable to front of the meter installations? So say communications with utilities for demand response, preventing backfeed when not desired, etc.
Sure.
Yeah, maybe Tom, you can touch on this, and maybe this connects with other initiatives at SunSpec.
Great. Yeah. Hey, great question. It's almost like I had somebody asking me to ask that one of me. Yeah, SunSpec is very much involved in interconnection and communications between systems and in the utility. And in that space, we're helping the state of California roll out its new California Rule 21 initiative that includes data communication for the first time. And so our testing and certification program covers that protocol as well. A little bit of history there. We were involved in the California Smart Inverter Working Group for its entire life, 5+ years. We were asked to, of course, contribute our ideas about communication. When it was settled that we're going to use the 2030.5 IEEE standard as the base for the utility to DER communications, we were asked to develop a test, certification, and compliance test for that particular technology and protocol, which we did, and it's available. It's free on our website, and it's the foundation that describes how California systems interconnect. So there's peculiarities, of course, with each of the major investor-owned utilities, and that's all. Those peculiarities and requirements are all captured in an addendum document called the Common Smart Inverter Profile, and we use that as a guide to configure that 2030.5 network, and then we test to that standard. So we're definitely very much involved in that. And as I mentioned, with the IEEE 1547 standard now requiring communications, we'll be offering certification on those communication interfaces in the 1547 context. And that covers any state in the union, and of course, many other jurisdictions around the world as well.
Fantastic. Chris, here's a question for you. Are there any current solutions to meet this requirement? I believe this is referencing NEC 2017 for residential applications, for single-phase applications.
Right now, we're currently working with Tigo on the TS4 ONS. Right now, we've been certified with the small Primo, which is the 3.8 to 8.2, with the Tigo solution. And then, as always, as soon as there's another third-party manufacturer that is able to do this as well with our equipment, we'd be definitely willing to certify with that. But for right now, it's Tigo on the TS4 ONS.
Great. Another clarifying question for you as well, Chris. Can you confirm the Symo 15 kW inverter is not equipped with SunSpec?
That is correct. So the Symo 15208 is not an advanced inverter. So that one is just a standard Symo inverter. We will be offering it in 2019. However, it's not capable of SunSpec compliance for rapid shutdown.
Yeah, I will add to that. What we see with a lot of the manufacturers is that noting that there were changes to the IEEE 1547 standard, a lot of them have tended to introduce rapid shutdown with smart inverters. And so this is a major trend. I think in the next few years, you'll only see, of course, smart inverters because of that 1547 standard. So that would be, I think, commonplace across different manufacturers.
Makes sense. Thank you both. All right. Want to encourage people to continue submitting questions here. We have a few more that we'll get to, and we will start to wrap things up after those questions. But I encourage you to submit if you have anything else on your mind. Great. So Tom, this one's for you as well. Just thinking ahead in the industry, are there areas where SunSpec has thought about applying standards, but perhaps manufacturers aren't necessarily focused or emphasizing those efforts right now? Do you see an area potentially in the next couple of years where there will be greater demand for standards in the industry?
Absolutely. The industry is standardizing as we speak. All of the relevant interconnection standards that I mentioned so far just seem to be adding more and more requirements for communication capabilities. And manufacturers, of course, are looking for solutions themselves, because with so many different jurisdictions to deal with and with the high volumes of each, it just becomes a real problem maintaining all these different SKUs. I mean, you as a distributor certainly recognize this. When you have to do special kits for a jurisdiction, that does nothing but drive up costs. So we see standards coming in across the board. Now, when SunSpec started, we took a very broad approach, because remember, I came out of a monitoring company, so we had to tie in string combiners and trackers and meters and batteries and lots of other things. And we have certifications for SunSpec Modbus across the board. But I'll tell you what's gotten the most traction in terms of adoption, and that would be inverters, smart inverters in particular, meters. That comes along as a natural complement to that, especially given interconnection requirements. Energy storage interfaces, and specifically in our case, battery interfaces, because we offer a Modbus definition, for example, and that is tailored to the different chemistries. So to lithium ion and to flow batteries, they have different performance and cycling characteristics. And so the communication signaling system has to vary so that we can get those key health parameters out. But that's an area we see standardization, because of course the pairing of energy storage systems with PV. And since the PV in the inverter already has to comply to the relevant standards, it only makes sense to use those same types of standards with the rest of your balanced system. So those are sort of the key driving applications that we see. And then in terms of the interconnection standards, Hawaii and California leading the way now, but I tell you, we see demand coming out of Australia, and all sorts of emerging markets are taking the lead, determining that they would like to have a utility to DER connection. And so I would expect that you'll see lots of communication networking applications coming on board. As the audience knows, that the majority of systems are already monitored. There's no doubt of that. Certainly commercial industrial systems, 100% of those. Residential, maybe not so much, but still a significant fraction. So the industry has experience with this. And so what we're standardizing on is a two-way communication, and in the case of California, making it mandatory for all systems, including residential. And so what this means, I think, for installer is that increasingly they're going to need to have networking technician capabilities on board. For our part, SunSpec's part, we're going to do our level best for the installer to turn it into a blinking green light, plug in the cable and go away. That's our desire. But meanwhile, data communication and Linux processors and the like are coming to a PV array near you. And therefore you need a standard.
Great. Great answer, Tom. Thank you. Funny, we actually had a couple very similar questions come in during that answer, Tom. And Chris, you might be able to speak to this one as well, but we have a few folks interested in hearing both of your takes on NEC 2020 down the road. Do either of you see any surprises coming? Are either of you in tune with the conversations that would likely be had leading into NEC 2020?
Chris, you want to take that one first?
So actually, I'm not in tune that much as far as what's coming on down the line for NEC 2020. So if you want to go ahead.
Okay, sure. Well, first I'll notice that NE 2017 is going to be adopted by some pretty major parts of the U.S. market in 2020. California lags one code cycle behind, so they'll be adopting and then immediately have compliance requirements for rapid shutdown. But as to what will be the content of NEC 2020, so what I've heard is that they feel that there are some cleanup that they need to do in terms of language and so forth. There were some confusing parts that they felt they need to clean up with. I think you're going to see in additional requirements potentially coming in around things that can leverage communication signal back out to the inverter itself. But what I understand is that the 2017 code cycle was a pretty major lift in terms of adding communication requirements in. So now, not explicitly, mind you, but implicitly, because there was really no other cost-effective way to address turning systems on and off with this type of requirement like rapid shutdown. So I think you're going to see an increasing number of those types of use cases coming in with the next code cycle. A commentary, I would say, on energy storage as well. I mean, that's a topic that comes up everywhere. So there will be some commentary on energy storage, I'm sure.
Makes sense. Yep. Thanks, Tom. And speaking of energy storage, a couple people on the line here. With the advent of the home battery market, a couple people are interested in learning about how SunSpec is potentially getting involved with grid battery PV combination systems and interconnects, and yeah, this is an area where Fronius has experience and is looking to get involved in. So I guess for both of you on that question.
Yeah, we have lots of companies that are involved with energy storage. I think in the future you're going to be hard pressed not to see really everybody that's involved in PV installations have something to say about how energy storage is integrated or dealt with. So if you go to sunspec.org and just take a look at the member list and email me, tom@sunspec.org, I'll put you in touch with any number of different parties that are working on this problem. But Chris, I'll let you speak for Fronius, of course.
Thank you. So as far as our product roadmap goes, right now we're capable of doing AC coupled systems. Now, later on down the line, maybe a year, maybe two, we should be looking at DC coupled systems for later on in that time frame. So I think storage is coming, especially with time of use poking its head around in states like California. It's going to be a requirement for PV installations down the line. People are going to need to offset their nightly usage. And that's just more forward thinking. It hasn't quite hit yet, but I have a feeling it will, and we should have a DC coupled inverter at that time.
Yeah, I will add that when this topic first came up of integrating energy storage, most of the activity was around DC coupling, and then most of the products that were introduced, in fact, were AC coupled. What we see now is a mix of both, and it makes sense. Again, for a retrofit application, the AC coupling is, of course, the most convenient. But in all cases, the particular application matters a lot in terms of what direction you want to go. But what will enable that, and I know I'm a broken record about that, this ability to reconfigure AC/DC systems and have them still work with your signaling system, and that's going to be communication standards underlying it all.
Got it. Thank you both. All right. Fantastic. Well, if anyone has any final questions, feel free to submit now. Otherwise, I just wanted to remind everyone who's still on the line here, if you're interested in receiving that NABCEP credit, please email me with NABCEP in the subject line. Had a number of emails already come through, so I thank you for that. I will get you those certificates by the end of the day tomorrow. For those who are still on the line here as well, expect an email by the end of the day today with a copy of these slides as well as a recording of the webinar, so you can go back and listen to any parts that you'd like to re-listen to. And we'll also include some handout sheets that are relevant to the webinar as well. Great. Well, I appreciate everyone's time here, especially the time of both Fronius and SunSpec Alliance in helping to put together this webinar. Thank you to Tom and to Chris for their contributions here. And we will see you in a webinar soon again. We'll let you know via email when we host our next. Tom, Chris, any final comments?
Yes, please come see us at Solar Asset Management North America in San Francisco. We're holding a workshop on California Rule 21 requirements and system integration. So that'll be on March 25th. And then the Solar Asset Management Conference happens the 26th and 27th. Really a great lineup. Again, this year, probably be 500 odd people there. So great place to learn and listen about new requirements coming down the line.
And Tom, I just wanted to say, thank you for having me, and thank you for everybody for listening. Please feel free to reach out to Tom directly or myself to get you some nice Fronius Symo advances from CivicSolar.
Definitely, we're proud to announce that we are now shipping the Symo Advanced line. So feel free to reach out to your account manager for any pricing inquiries, and we're excited to begin designing some systems around this for everyone out there. So once again, thank you to Fronius and SunSpec, and enjoy the rest of your day. Take care.
Bye for now.
Bye.